In the 1960s, there was a real debate as to whether or not humans created new neurons as adults. The people saying that we did make new neurons were young, less established researchers, and they were using new lab techniques. And the old guard didn't believe them. Now we know that new neurons get created every single day. In fact, every month, you'll replace about 3% of the neurons in your hippocampus, which means you're sitting there thinking with a brain that is very different than the one that you had 5 years ago. In this video, I'm going to discuss the brain's ability to adapt, and we'll also look at the effects of drugs on the brain. The first concept that we should look at is neuroplasticity. Neuroplasticity refers to the brain's ability to change and reorganize its structure and its functionality. This allows the brain to adapt, learn new skills, and recover from injuries. But the brain is rather limited in its ability to repair itself, which is why many brain injuries have lasting effects. Let's take a look at the most common form of neuroplasticity, which is memory formation. The current understanding of how memories form is that neural pathways are strengthened through repeated use. Imagine your neural pathways as a trail. The more the trail is used, the clearer the path becomes and the easier it is to use. Same goes for your neural pathways. This neural strengthening process is called long-term potentiation, and it's a big part of how we learn. Let's take a look at a real-world example. In the year 2000, a study was done on London cab drivers. They compared the brain scans of cab drivers to the brain scans of non-cab drivers. The scans showed that cab drivers had growth in their posterior hippocampus as a result of all the spatial memorization that they had to do at their job. So there you have it. The brain changes in response to your experience. And it should be noted that this trait can be negative as well. If a person goes through a traumatic experience, that can lead to growth in the amygdala, which can lead to persistent negative feelings of anxiety or stress. So your day-to-day life can change your brain. But what about substances that are essentially designed to change your brain activity? What are drugs doing to your brain? To answer this question, let's look at the three main types of drugs: depressants, stimulants, and hallucinogens. A depressant is a drug that suppresses central nervous system activity. The inhibitory neurotransmitter in our nervous system is GABA, so most depressants work because they're GABA agonists. These drugs will generally have a calming effect, so they're often used to treat anxiety and insomnia. Some common anxiety medications are Xanax, Valium, and Ativan, but the most commonly used depressant in human history is alcohol. And these drugs can be quite dangerous because your central nervous system regulates vital life functions. So if you suppress this system too much, then those functions can stop. And that's not good. Okay, let's talk about stimulants. Stimulants are drugs that tend to increase overall levels of neural activity. Many of these drugs act as agonists of the dopamine neurotransmitter system. Dopamine is the primary neurotransmitter involved in our psychological reward system, so drugs that act on this system can be highly addictive. Drugs in this category include cocaine, amphetamines, cathinones, also known as bath salts, MDMA, nicotine, and caffeine. Up next, we've got hallucinogens. Hallucinogens are a class of drugs that result in extreme changes to sensory and perceptual experiences. While under the influence of hallucinogens, people can experience really vivid hallucinations. It's also common for these types of drugs to change the way that you perceive yourself or the way that you experience the passage of time. And humans have used these drugs for a lot of different purposes over time. Hallucinogens like ayahuasca and peyote have been used in religious ceremonies by various cultures around the world. Another example is LSD. LSD's hallucinogenic properties were discovered in 1943 when a researcher accidentally ate some and then took the scariest bike ride ever. This drug was later used by the CIA in their infamous project called MK Ultra, where they tried to develop mind control drugs. Ironically, this drug was also used heavily by members of the counterculture movement while they were busy countering culture. Let's talk about addiction. Drugs vary in their likelihood to cause an addiction, and there are a couple different forms of addiction that we should be able to differentiate. Physical addiction is the type of addiction that involves the body becoming physically reliant on a substance. It often leads to the development of tolerance, which means you need more of the substance to achieve the same effect. And if you're physically addicted to something, then you'll get withdrawal symptoms when the substance is not used. Withdrawal refers to a set of symptoms that occur when a person stops using a substance. And these symptoms can vary depending on the substance or the behavior, and they can be quite uncomfortable or even dangerous. For example, if you become physically addicted to alcohol, then you've spent a huge amount of time suppressing your nervous system. If you suddenly stop suppressing it, then you'll have symptoms of neural overactivity like anxiety and a fast heart rate. And in extreme cases, it can be life-threatening. So rehabilitation facilities have to have medical staff who can treat people or ease them off the drugs slowly. Then we have psychological addiction, and this is more about the emotional and mental dependence on a substance or behavior. Individuals may crave a substance due to the pleasure or comfort that it provides. In this situation, you're not physically addicted. So for example, you're not physically addicted to Instagram or TikTok, but psychologically you might be. Okay, that about does it for drugs and neuroplasticity. In our next video, we'll look at sleep.